All right, welcome to chapter 6. We're going to learn about exponential equations and functions. So if we're looking at lesson 6.1, we have properties of square roots and the quotient property, the product property and quotient property. So when you have the radical symbol, right, the square root symbol, it's the radical symbol. Underneath is what we call the radicand. So we have x, y underneath. We can simplify that. It means the square root of x times the square root of y. All right? And we're talking where x and y are greater than or equal to 0. So let's look at what that means in numbers. So it's kind of like if we have the square root of 45. All right, this is what we're going to be dealing with today. If we have the square root of 45, we could take that and look for perfect square factors such as 9 times 5. Then we could break them up so that we could simplify them because the square root of 9 is 3. The square root of 5 is irrational, and we have to leave it as square root of 5. It would otherwise give us a decimal, right? But square root of 9 is a perfect square. We're talking about the perfect squares. Hopefully you know those, and you might want to look those up if you don't. All right, so the quotient property works the same way. If we have a fraction or a ratio underneath the radical symbol, we're looking at the square root of the numerator over the square root of the denominator. Remember, the denominator has to be greater than 0. So we'll take square root of 3 over the square root of 4. We'll get, in this case, square root of 3 over 2. Always, 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 you need to what we call rationalize the denominator, meaning we have to have it to be an integer. We cannot leave a radical in the denominator. We're not going to get into that until maybe chapter 9, where we'll do more in depth. We're going to focus a lot on simplifying like this. All right, so this is an example in your book, and I'll let you go ahead and look that up in your textbook. And we'll just try a couple. So we have the square root, so we can simplify this and say square root of 23 over the square root of 9. And then what gets simplified is the square root of 9. 23 is not a perfect square, nor does it have any perfect square factors. Square root of 9 is a perfect square, and that is the solution. For number 2, we know that we have Number 2, we know that we have the opposite of the square root of 80. So we can break 80 up. So one of the ways you want to do that, you want to say like, oh, if I want to divide by 2, and then that's 2 and 40, but then you can divide by 2 again, and then you can divide by 2 again, and you keep going. Or you say, oh, that's 4 and 20, and then 20 can be divided by 4 again. So the greatest perfect square factor is 16, and you could just practice and divide it out. So I'm going to go above here. I'll do blue. So the opposite of, we'll break it up into 16 times, and I believe it's 5. Right? If we didn't do that, we would just have to keep testing and making sure that what we have left is in simplest form and there's no more perfect square factors. So when we have this, we have the opposite of the square root of 16 and times the square root of 5. And that's going to be equal to the opposite of 4 square root 5, 4 root 5. Okay, for number 3, we're going to take the square root of 27 and put that over the square root of 100. I'm going to kind of go backwards here. In the numerator, we have the square root of 9 times 3, because 27 can be broken up into its factors of 9 times 3 over 10, right? Square root of 100 is 10. So this is equal to square root of 9 times square root of 3 over 10, which in turn is equal to 3 square root of 3 over 10. Always look then to see if there's anything else you can simplify, but 3 and 10 do not have any common factors. So number 3, the solution is right here, all the way up. It kind of went round and about. Okay, looking at number 4 to evaluate, we have A, B, and C, and we want to substitute those in, and they're under the radical. So we're going to follow order of operations. So you might need some parentheses to protect this negative number here. It's negative 4 times 2 times negative 5. So under the radical, I have 36, because negative 6 times negative 6. Then, minus, and then 4 times 2 is 8. 8 times negative 5 is negative 40, which then in turn makes it so that I would add it. So this is equal to square root of 76. Again, we want to look for some perfect square factors. You could divide by 2. You could divide by then 2 again, so we know we can divide by 4. So we have 4 times 19. So that's square root of 4 times square root of 19. So 2 square root of 19 becomes our simplified form by breaking it down. 19 has no perfect square factors. That's how we know we're done. Okay? If you need to pause the video, you can. All right. So in simplifying this one, we're going to first work with the numerator, and it's an expression. So we need to simplify the square root of 32. So I'm going to rewrite it, and then it's going to be 8 plus, and then 32 is going to be like 16 times 2, right? All over 2. So all I've done is factored that. I looked at 32 and I said, okay, 32 can be broken down into 2 times 16. And I can even break it down farther, right? Because we know that's 4 times 4, and then it's 2 times 2. So you can prime factorization if you kind of remember the factor tree. But this is a perfect square right here. So I can stop at the perfect square. So that's what you're looking for. So we want to rewrite this 8 plus the square root of 16 times the square root of 2, not a perfect square, all over 2. So 8 plus square root of 16 is 4. All right. Now right here, this 8, this 4, and this 2 all have a factor of 2 in common. So I could kind of, like I think today in class, I looked at it like that. Okay. And did a little triangle right there because you can't just divide one. You have to divide both. A way to look at that is say, well, I could factor out a 2, right? I could say, if I factor out a 2, I'm left with a 4 and a 2 here. But 8 divided by 2, what happens when you take 8 divided by 2? You get 4. So we would get a 4, right? That leaves 1 in the denominator. What is 4 divided by 2? It is 2. So 4 plus 2 square root of 2 becomes our simplified answer, and the denominator became 1. So 4 plus 2 square root of 2. Okay, we cannot add these, and we couldn't add these or add these because they're not like terms. They have to have the same radical. So 8 doesn't have a radical 2, so I couldn't combine these and make 12 radical 2, right? Unless it did have a radical 2. Okay, for number 6, I can look at this and I can say, okay, negative 1 minus, and then I know I'm going to have this 9 times 3 all over 4. So negative 1 minus the square root of 9 times the square root of 3, and that's over 4. So negative 1 minus 3 square root of 3 divided by 4. And is there anything that they have in common? So no, these 3 numbers right here do not have anything in common. So this is my final answer for this one. All right. And over here, I'm going to go ahead and leave the denominator like this. I could make it 6, but then in the end, I'm just going to have to simplify anyway. So I'm going to go ahead and leave it like this. So I'm going to work with this one here. So I'm going to say 2 minus, and then I have 4 times 7, because 4 times 7 are factors of 28. One of them is a perfect square. And all of that over the 2 times the 3. So 2 minus square root of 4 times square root of 7, all over 2 times 3. So this is going to be equal to 2 minus 2 square root of 7, all divided by 2 times 3. Now notice that we have a 2, a 2, and a 2. So those all turn into factors of 1, right? So my final answer becomes 1 minus the square root of 7 over 3. And that is my simplified as I can get. So go ahead and, if you need to pause the video to write that down, I'm going to go ahead and clear that. All right, new chapter. So go ahead and, if this is on an Edpuzzle that you're watching this video, go ahead and respond to these vocabulary and concept check questions. Let me know which one you are responding to. The theme quotes for chapter 6 are to inspire success. Just when the caterpillar thought the world was ending, he turned into a butterfly. All right. So if you have any questions, be sure to write them down so that you can ask them in class or leave them at the end of the Edpuzzle. Thank you, and I will see you in class tomorrow.